All right, so today we're diving deep into Carl Friedrich Gauss. And from what I'm seeing in these biography excerpts,
Right.
this guy was way more than just a math whiz.
Oh, yeah.
I mean, we're talking titan of science level here.
For sure.
And get this.
Okay.
Before he was even 25, Gauss had already figured out how to calculate the date of Easter.
Wow.
And not just some complicated method for mathematicians,
Right.
but a way that anyone could use.
Oh, that's impressive.
It really is.
Yeah.
So, I mean...
It's truly remarkable how Gauss's mind worked.
Yeah.
And you know what's fascinating is how his story really embodies that classic triumph over adversity narrative.
Okay.
We're talking humble beginnings here.
Right.
His father worked various jobs, and his mother could barely read.
Hold on. So you're telling me the guy who basically revolutionized math came from a background where education wasn't exactly a priority?
Exactly.
Wow.
And yet the stories about his childhood are almost unbelievable. Imagine a 3-year-old correcting his father's arithmetic.
No way.
Yeah, that's Gauss.
That's crazy.
Then there's that famous anecdote about him instantly calculating the sum of an arithmetic series.
Oh, yeah, back in elementary school, right?
Back in elementary school, exactly.
Okay, I've heard different versions of that story.
Sure.
But what I'm curious about is what it reveals about Gauss's approach.
Okay.
Was he just like a human calculator?
Right.
Or was there something more going on?
That's the key.
Yeah.
Even as a kid, Gauss wasn't just crunching numbers.
Okay.
He was finding elegant, insightful solutions that bypassed brute force calculation.
So he could see the bigger picture.
It's like he could see patterns and structures that others missed.
So it wasn't just raw talent,
Right.
but a different way of thinking?
Exactly.
Makes the story even more impressive.
It does.
But talent needs nurturing.
Of course.
The sources mention a duke who played a crucial role.
Absolutely. The Duke of Brunswick recognized Gauss's genius early on and essentially became his patron, ensuring he received the best education possible.
So without that support,
right,
who knows if Gauss's potential would have been fully realized?
It makes you wonder how many other brilliant minds might be out there.
Oh, yeah.
Just waiting for that chance.
Absolutely. But back to Gauss.
Okay.
You know, we often associate him with math.
Of course.
But these sources emphasize his contributions went way beyond that.
Oh, yeah.
Astronomy, geodesy, physics is almost overwhelming.
And what's fascinating is how these seemingly disparate fields were all connected for Gauss.
Okay.
Through his ability to apply mathematical principles to real-world problems.
No, this wasn't some ivory tower intellectual.
Right.
He was solving practical problems using theoretical brilliance.
Exactly.
Can you give me an example?
Sure.
How did this play out in, say, astronomy?
Think about the discovery of Ceres back in 1801.
Okay.
Astronomers found it, then lost track of it. Enter Gauss.
Okay.
He steps in, uses his newly developed mathematical methods.
Wow.
And predicts exactly where to find Ceres again.
No way.
This wasn't just a lucky guess.
Okay.
He used the method of least squares, a technique he pioneered, to analyze the limited observational data and account for the inherent errors.
So that's incredible.
This feat propelled him to international fame.
Wow. Okay, now that's what I'm talking about. A real aha moment.
Right.
So he's applying cutting-edge math to solve real-world astronomical puzzles.
Exactly.
That's amazing.
It is.
But the sources also mention something about Gauss being a bit of a perfectionist.
Yeah.
There's this motto of his.
Tarko sed matura.
What does that mean?
Few but ripe.
Okay.
And this wasn't just a quirky saying.
Right.
It reflects Gauss's entire approach to research.
Gotcha.
He was meticulous, incredibly rigorous, and hesitant to publish anything he considered incomplete.
So are we talking about a scientist so obsessed with perfection?
It's certainly a possibility.
Wow.
And it makes you wonder what might be hidden in the vast collection of unpublished work discovered after his death.
Ooh.
We're talking about a potential treasure trove of lost brilliance.
Okay, now that's a cliffhanger.
It is.
Speaking of potentially groundbreaking work kept under wraps.
Oh, yeah.
The sources bring up non-Euclidean geometry.
Huh.
Apparently, Gauss was exploring this decades before it became widely accepted.
Yeah.
Really?
It's one of those what-if moments in scientific history.
Okay.
Imagine if Gauss had shared his insights sooner.
Right.
But his reluctance to publish on this topic, possibly due to fear of backlash from the scientific community at the time, meant others got the credit.
Wow.
Lobachevsky and Bolyai, both working independently, published their work.
So they got the credit?
While Gauss remained silent.
Wow.
Yeah.
So we're talking about a brilliant mind, perhaps a bit too cautious for his own good.
Perhaps.
But what about the man behind the math?
Well, the sources paint a picture of a complex individual, incredibly gifted, but also reserved. Strict in his principles, yet with flashes of playfulness. He faced personal tragedies with stoicism.
It's interesting how someone can be so brilliant,
Yeah,
but also kind of reserved.
Yeah.
But he found solace in intellectual pursuits.
He did.
There's even a story about him learning Russian in his 60s.
Yeah, I know, right?
Wait, what?
It's amazing.
That seems so random. Why Russian?
Some speculate it was to better understand Lobachevsky's work on non-Euclidean geometry.
Oh, so the guy who got the credit.
Yeah, wow.
Which was published in Russian.
So he was learning Russian just to understand this other guy's work.
Yeah.
That shows some serious dedication to knowledge.
It really does.
That's amazing.
Yeah.
It sounds like we're just scratching the surface of Gauss's story.
I think so.
I'm ready to dive deeper into his work.
Okay. Especially his Magnum Opus Disquisitiones Arithmeticae.
Yes.
This book supposedly redefined number theory.
And it did more than just present groundbreaking findings.
Okay.
It laid out a systematic and rigorous framework for the entire field, influencing generations of mathematicians to come.
I'm intrigued.
Yeah.
Let's delve into this foundational work.
Let's do it. So imagine a book that doesn't just solve math problems, but completely changes how we think about numbers.
Okay, so we're talking...
That's Disquisitiones Arithmeticae.
Wow, okay.
Yeah.
From what I'm gathering, Gauss wasn't just finding answers.
Right.
He was creating a whole new language to understand those answers.
Exactly.
The sources mention this triple bar symbol for congruence.
Oh, yeah.
What's that about?
That's a great example.
Okay.
It revolutionized modular arithmetic.
Modular arithmetic.
Yeah. Think of a clock.
What's a modular system?
Right. It goes from 1 to 12, then cycles back.
Exactly. It goes from 1 to 12, then cycles back.
Gauss's symbol gave mathematicians a precise way to express relationships in these cyclical systems, which is essential for understanding things like prime numbers and cryptography.
Wow. So it's like he's creating a whole new way of thinking about numbers.
Exactly.
That's incredible.
It is.
Okay, so I'm starting to see how this book wasn't just about number theory.
Right.
It was about creating tools to explore number theory more deeply.
Exactly.
And those tools allowed him to tackle some of the biggest questions of his time.
Yeah.
Right, like quadratic reciprocity.
Oh, yeah.
Which the source is called the gem of arithmetic.
Well, it's a gem.
Okay.
It's a deep connection between prime numbers and their remainders when divided by other numbers.
So like...
Imagine you're dividing prime numbers by, say, 5.
Okay.
Some will leave a remainder of 1, some 2, some 3, and so on.
Okay.
Quadratic reciprocity reveals a hidden symmetry in these remainders.
So there's a pattern there.
It's like a secret code governing how prime numbers behave.
Okay, I'm sensing there's a lot more to that than we can cover here.
Oh, for sure.
But the sources also mention these things called binary and ternary quadratic forms.
Yes.
What are those exactly?
Think of them as equations with multiple variables.
Okay.
But all the variables are squared.
Huh?
Gauss developed a deep theory around these forms, exploring their properties and relationships.
So it sounds pretty complex.
It is complex.
Yeah.
But here's the key takeaway.
Okay.
This work laid the foundation for later advancements in algebraic number theory.
Algebraic number theory.
A branch of math that deals with abstract algebraic structures.
So he's not just solving equations.
Right.
He's developing entirely new frameworks for understanding the building blocks of mathematics itself.
Yeah.
It's mind-boggling how much of modern mathematics can be traced back to this one book.
I know, it's amazing.
But the sources mention Gauss kept pushing boundaries.
He did.
Even beyond the disquisitions. There's a section on his work with something called the fundamental theorem of algebra.
Yes, that's another cornerstone in mathematics.
Okay.
This theorem essentially states that every polynomial equation, no matter how complex, has at least one solution.
Okay.
Within the realm of complex numbers.
Okay. I'm going to need a little help here.
Sure.
What are complex numbers?
Don't tell me you should have paid more attention in high school math. Maybe not.
I understand.
Yeah.
So think of it this way.
Okay.
We have real numbers, which we use every day.
Right.
Then we have imaginary numbers.
Okay.
Based on the square root of line equal 1, which you can't get with real numbers.
Okay, so imaginary numbers are?
Complex numbers combine both real and imaginary parts.
Okay, so complex numbers include real numbers.
And imaginary numbers.
Gotcha. Yeah. All right. So the fundamental theorem of algebra tells us that even with these more abstract, complex numbers, we can always find solutions.
To polynomial equations.
Exactly.
That seems fundamental, I guess.
It is fundamental. It underpins a lot of advanced mathematics.
Okay.
And has implications for fields like engineering and physics.
So this is really important stuff.
And what's remarkable is that Gauss didn't just prove this once.
Oh, really?
He provided multiple proofs throughout his career.
Wow.
Each time refining and clarifying our understanding of complex numbers and their role in algebra.
So he kept coming back to it.
You get it.
So he was proving theorems.
Yeah.
Revolutionizing number theory. Even predicting the movements of planets.
Exactly.
Was there anything this guy couldn't do?
It seems like not.
The sources also touch on his contributions to something called analysis.
Oh, yeah.
What's that all about?
This is where we see Gauss's genius in moving between different areas of math.
Okay.
Analysis deals with things like infinity limits and functions.
Okay.
He explored elliptic integrals, worked on hypergeometric functions, and even laid some groundwork for what we now know as modular forms.
Okay, hold on. Elliptic what now?
Elliptic integrals.
Maybe we can break that down a bit.
Sure.
Yeah.
Imagine you have an ellipse.
Okay.
And you want to calculate the length of its curved perimeter. That's where elliptic integrals come in.
Okay.
They're a type of integral, which is a way of calculating areas and volumes.
Oh, right.
But they can't be solved using the usual algebraic methods.
Oh, wow.
Gauss was one of the first to grasp their importance and explore their properties.
So it's like trying to find the area of a weirdly shaped object?
Exactly.
But even more complex.
Little bit more complex,
yeah. These elliptic integrals show up in all sorts of unexpected places.
They do.
In physics engineering, even in calculating the orbits of planets.
Yeah, it's pretty amazing.
It's incredible how this guy was making waves in all these theoretical fields.
Yeah.
But the sources also mention that Gauss wasn't just an ivory tower mathematician. He got involved in some very practical work.
Yeah.
Out in the real world, right?
You're talking about geodesy.
Geodesy.
The science of measuring the Earth's shape and size.
Okay, so.
Remember how the Duke of Brunswick was his patron?
Right.
Well, part of that patronage involved funding an observatory in Brunswick. Gauss ended up overseeing a geodetic survey of Hanover.
So from pure mathematics to land surveying.
It might seem like a leap.
It does.
But it showcases Gauss's versatility.
Okay.
This practical challenge led him to develop new mathematical techniques and instruments.
Like what?
For instance, he invented the heliotrope.
A heliotrope.
A device that used mirrors to reflect sunlight over long distances.
Wow.
Which was essential for triangulation measurements and surveying.
So he's out there mapping the land.
Yeah.
Inventing gadgets. And I'm guessing he's still finding time to make groundbreaking mathematical discoveries.
Oh, absolutely.
This guy was unstoppable.
His productivity was remarkable.
It really was.
And his practical work often fed back into his theoretical pursuits.
Oh, wow.
His geodetic surveys led to new insights into the Earth's shape.
Okay.
Which influenced his work on potential theory.
Potential theory.
A branch of physics dealing with forces and fields.
So he's connecting his real-world work with his theoretical work.
Exactly.
That's pretty impressive.
It is.
Okay, so we've got astronomy, number theory, analysis, even adventures in land surveying.
That's right.
But the sources hint at another chapter.
Okay.
His research on magnetism and electromagnetism.
Oh, yes, another fascinating area.
This is with Wilhelm Weber, right?
Exactly, another example of how Gauss's collaborations sparked incredible innovation.
So they were like a dynamic duo.
They were.
So what do they do together?
Together with Weber, they founded the Magnetic Association.
The Magnetic Association.
An international network of observatories dedicated to studying the Earth's magnetic field.
Wow, so they were creating a global science project. Back in the 1800s.
Exactly.
That's ambitious even for Gauss.
It was a huge undertaking.
So how did they even do that back then?
They standardized measurement methods, established data collection protocols, and essentially laid the groundwork for modern geomagnetic research.
Wow. So they were really ahead of their time.
They were.
And remember, this was all before the internet.
Right.
Or even widespread use of the telegraph.
Exactly.
Speaking of the telegraph,
yeah.
Didn't Gauss and Weber have something to do with that?
They did. They built one of the first working electromagnetic telegraphs,
Great.
connecting the Göttingen Observatory
Wow.
with Weber's physics lab.
So they were sending messages through wires back then.
Harnessing the power of electromagnetism.
That's amazing.
It's like they were science fiction pioneers in their own time.
Yeah.
Right?
But alongside all these accomplishments, the sources paint a picture of Gauss as a man of contradictions.
That's an astute observation.
Yeah.
He was incredibly generous with his time and knowledge, mentoring younger scientists. Yet he also had a reputation for being reserved.
Right.
And somewhat aloof.
So he was brilliant.
Yes.
But maybe not the most social person.
It seems that way.
Even towards his colleagues.
Yeah.
He valued precision and rigor above all else.
Sometimes to the point of delaying or even withholding his own work.
What?
For fear of criticism.
It's fascinating how this titan of science, who seemed to excel in every field he touched, could also be held back by self-doubt.
Perhaps it's a reminder that even the greatest minds grapple with uncertainty.
Yeah.
The pursuit of perfection can be both a driving force and a burden.
It's a good point with all these contradictions.
Yeah.
There's no denying his massive impact on science and mathematics.
Absolutely. Gauss's contributions are so vast and varied.
They really are.
That his influence is still felt today.
I mean, we've talked about so many different areas.
From number theory to astronomy.
Right.
From geodesy to electromagnetism.
Yeah.
His work has shaped our understanding of the world.
And to think there's still so much we don't know.
Right.
The sources mention a massive amount of unpublished work.
I know.
Discovered after his death.
It's incredible.
What could be hidden in those notebooks?
It's tantalizing to imagine what other groundbreaking discoveries might be waiting to be unearthed.
It's like there's this whole other side of Gauss that we haven't even seen yet.
Maybe some revolutionary mathematical concept.
Right.
Or insights into physics that were centuries ahead of their time.
It's like a scientific treasure hunt waiting to happen.
Exactly.
It's exciting.
It is.
It's a reminder that even for a genius like Gauss, there was always more to explore, more to discover.
And who knows, maybe somewhere in those unpublished notes
lie
the seeds for the next scientific revolution.
Okay, I'm definitely feeling inspired.
Me too.
To dig deeper into Gauss's life and work after this.
Yeah.
We've covered a lot of ground today. From his childhood genius to his groundbreaking work across multiple fields.
It's been a fascinating journey.
It really has.
And it makes you wonder, what would Gauss think of the world today?
That's a good question.
How would his mind grapple with the complexities of modern science and technology?
I don't know. But it's fun to think about.
It is.
What do you think his most enduring legacy is? What's the one thing that stands out to you? It's tough to pick just one thing. You know? I'm really struck by how he could see the connections between seemingly unrelated ideas.
Yeah.
He wasn't just a mathematician, an astronomer, or a physicist. He was all of them, seamlessly weaving those disciplines together.
Exactly.
It's like his work encourages us to look for those unifying threads and push the boundaries of what we think we know.
What's fascinating is that even though Gauss lived in the 18th and 19th centuries, his impact is still felt in our modern world.
It really is.
His mathematical discoveries are the foundation for so many advancements. Like what?
Computer science, cryptography, even engineering?
It's mind-blowing to think how his work on these abstract mathematical concepts centuries ago is now built into the technology we use every day.
I know. It's amazing.
It really is.
Beyond the specific applications.
Okay.
I think Gauss's legacy is also about a particular mindset.
Okay.
A dedication to precision, a willingness to challenge conventional thinking, and a deep appreciation for the power of abstract reasoning.
So he was really a true innovator.
He was.
He shows us that true breakthroughs often come from venturing beyond the familiar and exploring the unknown.
So what does this all mean for you listening in right now?
Yeah, why should anyone care about Carl Friedrich Gauss?
Well, his story is an inspiration for anyone who's ever felt that spark of curiosity about the world. Gauss shows us that even amidst adversity, with limited resources and societal constraints, the pursuit of knowledge can lead to extraordinary discoveries.
That's a really powerful message.
And that You don't need to be a mathematical genius to appreciate the beauty and power of math and its ability to unlock the secrets of the universe.
Exactly.
I like that.
Gauss's life is a reminder that curiosity, creativity, and a relentless pursuit of truth can change the world.
Well said.
Thank you.
Well, I think we've successfully navigated the depths of Carl Friedrich Gauss's life and work.
I think so.
In this deep dive.
Yeah.
Hopefully you're coming away with a newfound appreciation.
I hope so.
For this scientific titan.
He was a remarkable individual.
He really was.
And maybe even feeling inspired to explore some of these topics further.
Yeah.
Don't forget to check out the show notes for links to more resources about Gauss. Non-Euclidean geometry, or any other topic that piqued your interest during our conversation.
Well, that's all the time we have for today.
Okay.
But thanks for joining us on this deep dive.
It was a pleasure.
Into the world of Carl Friedrich Gauss.
Yeah.
Until next time.
Yes.
Keep exploring.
Keep questioning.
Keep questioning.
And keep diving deep.
Keep diving deep.